forward. Hi, everyone. As I told you in today's class, I would be recording this for tomorrow since I'm scheduled for jury duty and won't find out until much later tonight if I actually have to go to jury duty. So I don't want this kind of hanging in the air. Even if I get selected, they still may not pick me for an individual jury. So that would mean I could possibly be available at the time. But just in case, I'm just going to record this and we'll say tomorrow you're going to watch the video. So this is on the second section on psychobiology. Okay, so let me get into slideshow. And we'll go from there. So let's see. Biology of the mind and behavior and the brain in action. So in other words, we want to start with the very basics. How does information get from your sense organs, eyes, hearing, ears, gustatory, taste, olfactory, smell, tactile, touch? How does our sense organs get information to the brain? And then how does the brain get information to the rest of our body as our reaction to that stimulant that we had? So we call that the neuron. Very important. It's the basic unit of the nervous system. It processes the the signals to send to other neurons in the muscles and organs. Some are dedicated to go to the brain, some are dedicated to go away from the brain to different parts of the body. And there are close to 100 billion neurons. That's many, many times the mega millions right now is. So there's a lot of them. And the interesting thing is they never touch. They communicate with chemicals called neurotransmitters. And we'll talk a little bit more about that in a second. So there are three main types of neurons. The sensory neurons, which get the information from our different sense organs. So if you touch a cup of coffee and it's warm, or some hot chocolate, you can feel that. Well, instantly when your fingers connected to this cup, the neurons took that impulse and took it to the brain so the brain could say, oh, that's hot or warm. That's done by a connection of literally thousands upon thousands of neurons that go from the sensory nerve using the motor neurons, which are connected to the sensory neurons by these interneurons, to get information to and from the brain. We call that a brain circuit, the ones that work together for a specific task. So you have the tactile ones, which again is touch. There's a series of brain circuits that just do touch. There's a series of brain circuits that just do visual for eyes. There's a series that does just auditory for our hearing, etc. So here's a neuron. And your book has some pictures of the neuron, but I'll give you a little bit of hint. When I test, since not everyone in my college classes can afford to get the brand new textbooks, so sometimes they'll buy the older version. So the pictures don't always match up. So if you want to know what pictures to study the ones that are on the PowerPoint. The ones in your book are really cool, but said in not all of my classes, people have the same textbook. So I want to make sure that everyone has access to the same material that might be on the test. So pay attention to this. So out here we have the dendrites, and the dendrites are where information comes into the neuron. Right here we have the cell membrane, and this is known as the cell body, or the soma, S-O-M-A. Then an impulse, if the neuron is excited, this impulse will move along what we call the axon, this long, windy, twisted, part of the neuron. It's covered by a material called myelin, which helps speed the transmission of the impulse from one end of the neuron to the other. And at the very end of the neuron, we have what are called the terminal buttons. Now, sometimes people get terminal buttons mixed up with dendrites. Dendrites are at the beginning of the neuron, and they kind of look like tree branches, whereas terminal buttons are at the end, and they almost look like a little button, or somebody suggested one time they kind of look like E.T.'s fingers. E.T. phone home, right? So whichever way helps you to remember that the dendrites are at the beginning of the neuron and the terminal buttons are at the end. Now, the neuron is sitting there waiting to fire. And what we mean by that, it's waiting to send an impulse, just waiting and waiting. So let me give an example. Have you ever done the wave? You've gone to a football game or a basketball game, and everyone does the wave, the woo, but you don't go when to the person in front of you went, and then to the person in front of them went. And it works really, really smoothly as long as everyone remembers to do their part. Well, the same thing works with neurons. It's that type of pattern. One will fire, and then the other one will fire, then the next one will fire, and it just goes down the row. Except, problem, sometimes you have some neurons that are not functioning properly. So there can be an issue. And then you find disorders like MS, multiple sclerosis, which would be a good paper topic since I'm dropping paper topics right now. That's one of the reasons we know that deterioration of the myelin sheath on the neuron means the impulses have a hard time going to the end of the neuron. So therefore, a slower response, or maybe even a break in the response. Now, there's just not one neuron. I mean, there are, as we said, billions of them. But if you have enough damage to enough neurons, you start to see a pattern resulting from that. Not able to move your muscles, very stiff joints, lots of pain, etc. So the neurons at resting potential, waiting to go, we call that action potential that's coming along, firing. And it's all or nothing. There's no half, okay? My best way to describe this would be, again, think of the wave. So if people were like, woo, if you had someone kind of go, eh, that's not going to work. There is no eh. It's either this or nothing. There's no in between when we talk about neurons. It's either going to fire or it's not going to fire. And once it fires, it goes back to resting potential, waiting to fire again. Okay? So it's all or nothing. We already talked about the myelin. The myelin sheath acts as an insulator that helps that impulse travel more seamlessly and more effectively to the end of the neuron. And as we said, the deterioration of the myelin can lead to multiple sclerosis. So if we were actually in a classroom, we would do this as an activity. It's kind of hard to do on Zoom, but it's the same thing. If you would hold the hands of a couple different people, say, I mean, there's 7, we need 16. Let's say we have 16 people, and they're all holding hands, and I say go, and you're to squeeze the hand of the person next to you, and then they're going to squeeze the hand of the person next to them, and it's going to go right down the row. How long would it take for the first person who squeezed the hand of the next person to go all the way to the end and then tell me to stop counting? And most people guess, well, there's 16 people, 16 seconds. Some will say 9 seconds or 8 seconds. But the real answer, it's about 2 to 3 seconds to go through 16 people. And people were amazed, like, why? Because again, the person has to hear me say go. The information, the word go, has to go to their brain, and their brain sends a signal down to their muscles of their hand to squeeze the other person's hand. The other person feels the squeeze because the neurons have gone up to the brain and said, hey, somebody's squeezing my hand. Oh yeah, I'm supposed to squeeze the other person's hand, and it would have to go up and down 16 people. You would think that would take a long time, but it takes 2 to 3 seconds, depending on how quick my acting neurons are, okay? So the brain is very complex, and I don't want you to get, just dragged down with the, amounts of neurons, like knowing all the numbers, but realize there are a lot of neurons there. So we're talking 10 trillion neuroconnections, 10 trillion neuroconnections. So remember we were talking about those terminal buttons. Well, there they are. So here's the terminal button of one neuron. And on the other side, we have the dendrite of the next neuron. And see, they do not touch. They're closely bound together, but they do not touch. They communicate with the other with neurotransmitters. So the impulse comes along this neuron. We have these little vesicles in the terminal buttons that hold the neurotransmitters, and there are a lot of them. And when that is released, it goes into this area, which we call a synapse. It's this word, synapse. Sometimes you'll see it written as a synaptic cleft or the synaptic gap. All the same thing, just a matter of semantics, how people want to write it in your book. It's the exact same thing. So we got the synapse here. And there are these little receptor sites on the next dendrite. Remember, that's the one with the tree look. And those chemicals that are released are called neurotransmitters, are going to bind themselves to the different receptor sites. And it's those neurotransmitters that are going to make a difference if this neuron, this new neuron, is going to fire or not. Because remember, the neuron's just waiting there, like action potential. So you watch TV, I'm sure, and you can watch and hear all sorts of type of commercials for, pharmaceuticals, buy this, if you have this for diabetes, if you have this for depression, so I'm sure you may have heard of drugs like Prozac or Zoloft or Paxil. These types of drugs many times are used for depression because they are what they call SSRIs, selective serotonin reuptake inhibitors. So what does that mean, right? It means when the serotonin, which is a neurotransmitter, is released into the synapse, it causes that neurotransmitter to stay there in the synapse to the receptor site in hopes that it will encourage the next neuron to fire. Serotonin is a mood elevator. It lifts our mood. So, if you're happy and joyful, there's a good chance there's a lot of serotonin and a lot of dopamine going on, in your brain. So in this case, serotonin. So what Prozac and Zoloft and Paxil do is leave that additional neurotransmitter chemical in the synapse in order to hopefully get the next neuron to fire, which was having a little difficulty doing it all by itself. Okay. So now we move to the nervous system. We have the central nervous system, which is the brain and the spinal cord. Okay. And as part of the nervous system, we have the peripheral nervous system, which includes the autonomic, that means automatic, and the sensory somatic nervous system. And that's kind of the everything else, kind of, when you don't know where to put something, it kind of falls in that category. So that's kind of the category there. But for psychology, we really focus more on this system here, the autonomic nervous system. Okay. And in particular, we look at the different things that are controlled by it, certain things that you do every day and wouldn't think about it until I just say it now, like blinking. And all of a sudden you became aware that you were blinking. Breathing, you breathe. Your heart beats. Your digestion's still going on. Insulin is being released in your body. Cortisol, a stress hormone is being released and can have a lot of effects on your body. So all these chemicals are being released, different things are going on, and you have nothing to do with it. If you had to think, I need my heart to beat and I have to breathe and I have to remember to swallow, you wouldn't be able to do anything else. You would never be able to sleep. You'd never be able to talk with your friends, nothing, because you'd spend the entire moment of your entire life just trying to keep yourself alive. So thank you for the autonomic nervous system. But one of the key things that kicks in with the autonomic nervous system is what we call fight or flight. Fight or flight is what we call the stress reaction. It's basically the alarm phase. Our body will go into kind of like a defense mode if our brain recognizes things in the environment, whether they see it, hear it, there's a billboard, they smell like smoke if it was like a fire. As soon as the body recognizes that as soon as the brain, recognizes that the body is in danger, it goes into what we call fight or flight. So that happens naturally. You don't even know. I mean, it is literally a split second when it happens. So it raises your heart rate, it raises your blood pressure, it raises your respiration. Certain other chemicals are released in your body, some adrenaline to give you some energy, but also cortisol, which is the stress hormone. And we'll talk a little more about cortisol, but for right now, just know that's not necessarily a good thing because it's what regulates your metabolism. And if and what gets taken into the cells for energy, when you're in fight or flight, that nervous system reaction, your body stores fat to try to keep itself safe. And a lot of people who have difficulty with their weight will find out if they talk to a nutritionist, it isn't that they're necessarily eating bad things. It's the metabolism also is not really functioning the way it should because they actually may be under stress. So the sympathetic and the parasympathetic kick in. So the sympathetic is when you see something. So let's see, you're walking through the woods and there's a bear. Instantly, your body goes into fight or flight. And then eventually, when you see there's no danger, it was maybe not a bear at all. Maybe it was just a coat blowing in the wind. Then the parasympathetic kicks in and lowers all of those particular things in the body. Lowers your heart rate, lowers your respiration, lowers your blood pressure. Now, some people have a hard time thinking, well, why would it take so much longer to slow it down? It does. It's just an instant to get it up, but the body is trying to be protective of itself. So it's making sure, and again, this is all autonomic. It's not a, planned things, it's part of the autonomic nervous system, that it will just slowly come down by itself. Okay? Maybe you can think of a situation where you were frightened or scared, and all of a sudden you're like, and then it wasn't instantly you stopped doing that, but maybe about 5 or 6 minutes later, you kind of calmed down and everything was okay. So here we go. Sympathetic, emergency preparedness, fight or flight, it increases arousal. Parasympathetic decreases arousal. Here we have the corpus callosum, which connects the two hemispheres of the brain. So the brain is into, we have right and left hemisphere, and the way they communicate with many, not all, but many bits of information is through the corpus callosum, which is a thick fibrous material. And when we talk about how the brain works, what you see with, say, your left eye actually goes to your right hemisphere, and the opposite would be true. Or if, let's say, somebody would have a stroke, which would be another good paper topic, somebody would have a stroke and it's damaging their ability to, say, move their right arm, then we know the stroke is in the left hemisphere. It's always opposite. Okay, so the one part of the brain that controls the other side of the body, it's always the opposites. So we do have the lobes, and we're going to talk about the different lobes. We already talked about the corpus callosum. This is the cerebral cortex. This is where everything happens. I mean, this is, your executive functioning, your motor coordination, all your functions of your body. So you do try to protect this. And this is also why we say concussions can be a good paper topic, because if you get a concussion that affects, different parts of the brain, it can have different outcomes. I had a student who was a football player here at Central, and one winter he was sled riding, and of course at that time you wear helmets, and he hit a patch of ice as he was sledding down the hill, and he went head first into a tree, and he lost part of his memory. He remembered things of old, but he couldn't remember like the last 2 years of his life. It was like he didn't remember his friends, who his teachers were. If it was prior to the 2 years, he was okay. But if it was the last 2 years, and I can remember him eventually coming back, hey, Mr. Blasky, I know I'm in your class, but I have no idea where I sit. I don't know what we're on or what we're covering. He was in the hospital for quite a while. Eventually, he got much of his memory back. He did not get all of it back, but he did get much of it back. But he also then was limited. He was not permitted to play any type of contact sport for the rest of his life. because it was that severe of a concussion that the next one may do major damage and he may not recover from that one. Okay? So take care of your head. So we're gonna do this one lobe at a time. So this is just kind of an overview of the lobes. So in the back here, we have the occipital lobe. Occipital sight is a good way, vision, to remember that. The temporal lobes, or think of your temples of your forehead. Parietal, it's kind of like the crown of your head. And then the frontal lobes, that's probably the easiest one because it kind of gives it away. The frontal lobes are here. So let's start with the occipital lobes, the occipital on the back. Again, visual processing. And if you ever do hit your head and you see stars or like a flashing light, then this is the part of the brain that was damaged with the concussion, because it's the only part that gives you that like bright stars. And then you might pass out, but you got that bright light effect where the other ones do not. And then when we talk about the temporal lobes here on the side, language comprehension. So in other words, if you understand what I'm saying right now, that's your temporal lobe. Sound processing. So if you can hear what I'm saying, that's your temporal lobe. If this is new information for you, that's your temporal lobe. And visual images, and that's why I chose to use nice color-coded, lobe pictures here, because that actually will store in your temporal lobe and will help you remember the information better. Parietal, again, it's kind of the crown, rear, and the top of the brain. And the parietal lobe, attention. So if right now you're able to focus on what I'm saying, other than doing something else like, playing with your phone or having a side conversation with someone, or maybe doing your homework for another class, then your parietal lobe is working because it's helping you to keep attention. And it also helps us with spatial location, our surrounding, finding our way around, feeling comfortable in a space. Okay, that would be spatial location also. And the last one, I'm going to move this little thing out here, is the frontal lobe. And the frontal lobe is where all of our executive functioning takes place. If you damage this, it's going to make a huge difference, okay? So all your planning, searching your memory, all your motor processing, all your reasoning skills, in other words, all those executive functions that make us who we are, and many psychologists believe that this area is also kind of the home of our personality. And this is why. I don't know if you've ever heard of Phineas Gage. Phineas Gage was a railroad worker, and this is in the time where we didn't have all the modern machinery. In order to lay the rails for the track, that was all hand done. You had to, make holes and, put these long wooden tie rods in, etc. And typically before you put the blasting powder in, you would put sand in. So when you would tap it down, you wouldn't get a spark, which would ignite the gunpowder. And then, of course, that would be problems. Phineas Gage was an awesome guy. Everyone seemed to like him. He seemed to get along with everyone. His family liked him. He wasn't a person who called off work. He did his job. He did his job well. Well, one day he somehow forgot. We all do occasionally. And he forgot to put the sand in. And this tie rod went up behind his occipital area through the frontal lobe. So this little graphic here, and damaged this frontal lobe area. So it's a really interesting story, and there's some myth to it too, because we do have the research that says he changed fairly dramatically. Like from a nice guy, he became really mean and short-tempered, and he actually lost a job, and didn't treat his family. People said it was like Dr. Jekyll, Mr. Hyde. He was like a different person completely. But when you do a little more research, it found that as he began to heal, some of those original characteristics came back. So that could be a paper topic if you wanted to research Phineas Gage and information on damaged different parts of the brain and how it can affect a person. And I'm going to stop on this one. This is going to be our last slide that we're going to do today. And this is called the strips. And again, it's not something you have to memorize. But what they did was they cut the corpus callosum and lay the two hemispheres of the brain down. So you have the motor cortex over here, and notice you have toes, foot, leg, knee, hip. If you look on the other hemisphere, you have toes, foot, leg, knee, hip, but you also have genitals. You don't have genitals over here anywhere. So if you would damage this part of the brain, that part of the brain function, it has to do with genitals, you would have problems with your genitals. That's what happens when people have strokes, or if people have, accidents where they have a concussion. Different parts of the brain may be affected. If you have it on both hemispheres, we call your brain being plastic. It can actually manipulate around things. But if it's only in one place, not so good. So just look over this, just so you get an idea of where in the brain different functions are. So on that note, I am going to stop this PowerPoint. Let me get out of this, stop the share. Okay, and that's our lesson for today. So you should be keeping up with the reading. You should be on Blackboard. Everything should be open now. As I said yesterday, I went through, there were a couple documents that were still not accessible by you because they were hidden from view. I opened all of those, so all the documents and everything are open for the entire course for you to look at your convenience. And I hope you have a great day, and I hope to see you on Friday. And I'll let you guys know if I get selected for jury duty. So have an awesome day and take care.